So, something that is a big deal that people may not have thought about is that we're running out of good sand, and the sand that we have getting is causing great environmental disasters. Now, first you might be like, sand is everywhere. You're correct, sand is everywhere, but the sand we can use for construction isn't everywhere because desert sand turns out to be too spherical. And that means it doesn't stick together, it kind of rolls around too much. Well, sand from not from the desert, from beaches and water that's more fresh, and not every place is in streams. Those sands are what we use in construction and have certain grain size and certain types for certain projects. I'll link this article below, and there's a lot of other people, of course, but there's actually cartels battling for sand. In the last few decades, the demand for sand has more than tripled, special type, and every year hundreds of people have died by actual gun battles to cartels to accidents in unsafe working conditions. Coral reefs are being destroyed, coastlines are being eaten up at an amazing fast pace, and all these other awful things. But I think there's might be a solution from two parts. One part is that a lot of the sand is used in construction might have alternatives. Now, okay, some of it is replacing this cement and concrete in general, such as plastic building materials, which some people have developed, like plastic, which I'll link below, plastic Lego blocks. They're almost like Lego blocks, they're not like Legos, to work instead of concrete blocks. Other better construction materials that just replace cement totally in concrete. I should be saying concrete more. Concrete is cement when they add additives. Sometimes cement has sand, sometimes they say no sand, but concrete is when they definitely have other stuff. Some people add alternatives to sand to concrete you can add, which is everything from fly ash, which is ash from power plants and stuff, to small plastic particles, to carbon nanotubes, stronger materials, and the strongest known materials, but they're more expensive. But with new processes like C2CNT, they might become a lot cheaper and affordable. And even if you just don't replace this sand but make this concrete a lot stronger, they need to use less. That's also still an advantage. Now, sometimes people use sand in other things like making a stable base, and you don't want jiggly sand then because you want sand that stuff gets stuck into, and other things sand might be a lot harder to figure out. Another alternative is just to use different sands for different industries, such as the solar cell industry. You might have a different type of sand in the non-solar cell industry, because the solar cell industry, the shape and the grain structure doesn't matter as much. It's more the chemical composition. So you can also argue like different industries could have different sands. So reduce, make it so different types of sand. But I have another proposal, and that is we can turn bad sand into good sand, I think. Now, there's a lot of things that you would have to try out to see if this is practical or not. So it totally might turn out not to be a practical idea. But it's also fully solar powered, which is also cool. But sand has, my basic idea is if you have a round grain of sand, you can either crack it into non-round grains or make surface cracks that it gets more rough and can more easily attach to other cement sands, or it has more cracks in it that cement can fill in those cracks. It makes it bonded to the cement more, so it's more strong. Or you can not melt it, or not even fully melt it, but just make the surface strip so it becomes a different shape. So it can deform into a different shape by heating it up and cooling it down rapidly. So one thing to point out is that sand melts at a pretty high temperature, 1,550 degrees Celsius. However, I don't think we need to fully melt it to deform it. If you have a blast of hot air, you just need to melt the surface a little bit of each particle, and that way they don't stick together too much, that you have to unmelt the whole thing, that just the surface melts. So you don't have a solid piece of glass. You just have to, you might drop in cracks a little bit, but you don't have a solid piece. And you can fuse maybe in a temperature just to melt the surface, or fuse different grains of sand together so you get shapes that are not round, but like two circles or spheres fused together. It's not that much, but it might crack and become more smooth later on. But those cracks between it will, when your mechanical crafts, are probably going to crack in uneven ways that still make more surface area, like flat edge faces. Or other ways, or it might make very small, fine particles that have weird shapes. You might have total fine particles though. You might have to filter them out, because fine particles might be a breathing hazard. So you might have to dump it a few times, which will add energy cost, just to kick up any dust or dirt, which might also pick up more, but it might also just waste a lot of energy. Again, a lot of this stuff is kind of more than kind of theoretical. Now, the other thing is quartz inversion. So quartz has different types of structures, and at around 573 degrees Celsius, it turns fully from an alpha structure into a beta structure, and when it cools down, it turns back. But this is not an even, nice occurrence, and if it does it faster in some places than other places, it gets huge cracks and can fall apart. And these cracks that fall apart means that we only probably have to heat up to 573 degrees Celsius to really cause much damage and not fuse it. And that course will be a low temperature for fusion. Now, 573 degrees Celsius is a full conversion. That doesn't mean a partial occurs and cannot go below that. Then we have impurities in sand, which will actually lower all these temperatures because different things heat up differently. Now, how do I propose to make it so that so then the proposal comes that I want to make the heating of each in the grain of sand as uneven as possible, and I would also prefer to heat out the outside that can just crack away or fuse the outside of other particles first. Then that would save the most energy, because maybe I don't even have to heat up that inside the innermost. How would I do this? Well, I propose heating up some air and blasting that air through. Air doesn't, if you blast a quick blast of hot air, it might only have time to heat up the outer surface, but it's going to heat up the outer surface really fast. But it's not going to have time between, if it's just a quick burst, it's not going to heat up the other thing. And then it's going to, after a while, the heat is going to travel inside the sand particle and it's going to become more even temperature. So first the outer surface might be 800 degrees Celsius, but when it comes into the inside, but then the very, very outer surface of each sand, but then when it comes to the inside, it's only, after a while, after 10 minutes after blast, it might only be 400 degrees Celsius. Then you hit it with another blast after it gets more of an even temperature. And that other blast is then going to heat up the outer surface even faster, because now it has that outer heat, but it also will go more depth, and if something already cracked away, it's going to hit the new outer surface from the cracks stuff, and that cracks are going to form into that, and more, and it's going to keep just making more cracks and hitting more surface areas in different ways, and it's going to, until it reaches the temperature that it's good. Now this process might be highly variable for different types of sand, which would be a huge problem, because then how do you adjust it? You could do batch testing where you make a bunch of it, test it under a microscope, and then see how it does it. Or you could do testing where, another one is you could do testing where you move the whole sand grain, you move the whole sand thing and see how it moves, how it flows. Like, does it flow smoothly? Or does it bunch up like the sand you want? So if it doesn't flow smoothly, it's good. You could even argue that you could even do it with this, and that say that more jagged sand is not going to have as smooth airflow as less jagged sand. So maybe an airflow meter at the end sees how much how evenly the air flowed through the whole thing, that might be able to do it. And see, like, did it stop doing it? But you might have to readjust that. So it might be a partial sign with other methods being used to back it up, but it's being like a first test, or you do that test less often, and you have to adjust it for parameters. Another idea you could do is you could take this whole thing, and you could put the thing that sees how well it flows within the actual device. And that way you could have a mechanical thing, like a corkscrew or something, that is constantly turning up sand from the bottom and taking it up, and then sand on the sides come down. And you can see how much energy it needs to do that. If it needs a lot of energy, then you know that you're finally done. This could also lead to more grinding as sand particles start grinding next to each other and cracking. Now that could either smooth it out or make it less smooth. Smoothing out would happen at times. Depends on whether the going up and down causes more cracks or whether it causes more smoothing. You could also put maybe an ultrasonic sensor in to see how sound waves flow through this whole thing. And sound waves would scatter different. Sound waves could help crack the sand a little bit if they're intense. But if they're not intense, they could also tell it, and different types of particles scatter light differently and also different densities. And the cracking and stuff should eventually make the whole thing more compact as stuff tends to crack and fall together. So you can look at the density change and see when it hits some static medium. I'm sure with a combination of these ideas will work, but I'm just not sure what combination. This all sounds power intensive, but keep in mind that transporting sand from all over the world, from India to the US, which often happens, is very energy intensive. And if you can make it more domestically, that would save a lot of power. And then you have also digging up from the ocean floor and everything. Then you have all the power consumed by environmental disasters being caused, such as coral reefs being destroyed, so you get more CO2 in the atmosphere, or streams or swamplands. So it might be worth the energy penalty. Plus, this can all be solar powered with the heat, and heat is one of the most efficient things to collect from the sun. Thank you very much. I hope you found this interesting. Please like it and subscribe. It really helps the channel out. Goodbye.